We're still on 8.3, analyzing geometric sequences in series. This is the third video, and we're going to write a rule given a term and a common ratio. In the previous video, you could figure out the first term and the common ratio, but now we're given a random term and the common ratio. So let's give this a try. So we're going to write a rule. The number 5 gives us the fourth term. That's what a sub 4 means. And it gives us the common ratio. Well, when I have my actual rule, I'm going to just write it over here. an equals a1 times r to the n minus 1 power. So I have to have a1, not a4. So I'm going to take what I was given, and I can plug this in. I can say, okay, well, if I say this is an when n equals 4. So I can plug in an and n, and I know r. I can use those to help me find a1. Okay, so if I say an is 12, I don't know a1, but times r, and r is 2. And then n here is 4, because on the fourth term, which means n being 4, my number was 12. So that's where I'm getting this. I'm using this to plug in. Okay? So I get 12 equals a1 times 2 cubed. Okay? And 2 cubed is 8. So I get a1 equals 12 divided by 8, and that simplifies, let's see, to 3 halves. So this a1, and I'm going to use r and a1 and write my rule. Alright, so an equals 3 halves times 2 to the n minus 1 power. There's my rule. After I find a1, once I have r and a1, I ignore this first point after that. Okay, we're only using that to help us find the piece we don't know. Now, just to show you what these graphs look like, so if you're given a graph and you have to determine if it's geometric or arithmetic, if you remember, arithmetic made straight lines. Okay, so let's try it on. I'm just going to graph this one while I'm on this, just so you can see one graph. Okay, so I'm just going to plot some points. If I plug in 1, I get 3 halves. If I plug in 2, 3, 6, and 4, 12. Other than that, it's going to be off my grid. So I see that 1 and up at 3 halves, 2, 3, 6, 4, 12, 1. And it's like way up there, okay? So you can see what this graph is looking like. Okay? It's getting taller very, very quickly. Okay, just wanted to show you that. Alright, number 6. Now this time it gives me the 5th term and the common ratio. So remember our rule. Okay, so I need that first term. I already have the common ratio. I already have this, but I need a1. So I'm going to take, if n is 5, then a sub n is 32. So I'm going to plug that in, what I know, in my equation. So I'm going to get 32 equals a sub 1. We don't know what it is yet. I know r is 2/3, and it's n minus 1, so 5 minus 1. So I have 32 equals a sub 1 of 2/3 to the 4th power. Okay. So if I take 2/3 to the 4th power, I'm going to just move up here, 32 equals a1 times, let's see, 4th power would be 16 over 81. And I need to divide both sides by that. So 32 divided by 16 over 81, I get a1 equals 162. Alright, so now I have my r, I have my a1, and I can plug it into my rule here. So an is going to equal 162 times 2/3 to the n minus 1 power. And there's my rule. So give this a try by going to the practice and doing numbers 2, 24, 29, 31, and 32. One thing I want to point out with number 2, when I graphed this graph, this should look very familiar to you. It looks like an exponential function, like it gets smaller here if I kept going. Okay? Hint, hint. All right.